Hello, assalamu alaikum guys. Uh, Welcome to our lecture today. Today we are going to talk about something very interesting related to matrices, and that is called determinants. Do you remember when we talked about the inverse of a 2 by 2 matrix? So when you have here a matrix, let's say A, B, C, D. Do you remember when we said A inverse is D over AD minus BC and A over AD minus BC, and here negative B over AD minus BC and negative C over AD minus BC, and we said AD minus BC should not be 0. Well, if you look at this quantity here, that is crucial in deciding whether your matrix is invertible or not. Okay? This quantity here is what we call determinant of A. So determinant of A here is AD minus BC. So basically, if you want to decide whether a 2 by 2 matrix here is invertible, all you need is to look at the determinant, okay? AD minus BC. And that motivates a question: if we have a 3 by 3 matrix or an n by n matrix, do we have a quantity like that that will do the same job? And the answer is yes. We can define the determinant of a square matrix. It doesn't matter whether it is 2 by 2 or 100 by 100 or a million by million, okay? For 2 by 2 matrix, you can say here it is. If you are talking about 1 by 1 matrix, then you can say determinant of B is just A. And the question now, what if we go to a 3 by 3 matrix or 4 by 4 matrix or a general n by n matrix? Okay. By the way, sometimes I write determinant, or we can say determinant of A, or some people, they like to write it like this. So whether you see determinant with capital D or determinant with a small d or absolute value of A, we mean by that the determinant. Okay. So it depends which book you use or which professor you listen to. Different people, they like to write it, but all of them, they indicate the same thing. So let's now develop an approach for finding the determinant of an n by n matrix. Okay. Well, to do that, I need to talk about something called minors. And here, something called cofactors. Let me clarify that on a 3 by 3 matrix, and after that, we write the general formula for an n by n matrix. Let's say here your matrix A is A11, A12, A13, A3, A21, A22, A23, A31, A32, A33. We associate each entry in A with a quantity called the minor that is associated with that specific entry. Okay? For example, if we are talking about A11, we associate this with minor M11. And what is that minor M11? You cover this row and this column, and you take the determinant of what is left. So this is going to be determinant of this. A, 2, 2, A, 2, 3, A, 3, 2, A, 3, 3. Which is, based on what we know from here, that is A22, A33 minus A23, A23, A32. Okay, so the minor that we associate with A11 is this quantity. Look, this is a number here. Okay, all right. Well, I'm not going to list all of them, but let's say here we want to take this entry, A32, A32. We associate this with M32. And what is this? This is determinant. What do? We cover this column, this row. So what is left is A11, A13, A21, A23. And what is that? That is A11, A23 minus A13, A21. Okay? So now you can think about the minor that belongs or that you can associate with each one of those entries. So now you can take A33, so you cover this row, you cover this column, and you take the determinant of what is left. Okay? So you can observe here, if you are talking about 3 by 3 matrix and you want to write the minors, it is going to narrow down to writing determinants of 2 by 2 matrices. Okay? So for a 3 by 3 matrix, you need to find 9 minors. Each one of them is the determinant of a 2 by 2 matrix. Okay? What about the cofactors? The cofactors again, we associate each entry by a cofactor, A11. We associate that with the cofactor, C11. And C11 is going to be -1 exponent 1 plus 1, M11. So the difference between the cofactors and the minors is going to be in the negative sign here. Okay, of course here the 1 plus 1 is 2, so the sign is the same. But if you are talking about A32, that is going to be C32, and that is -1 exponent 5, M32. So here you are going to get a negative sign. Okay? So the signs, I mean, if you don't want to write -1 exponent I plus j or whatever you have here, you can think about it positive, negative, positive, negative, positive, negative. So you start with positive and you alternate as you go along the first row, then as you go down to the first column. Okay? All right. So let's take a specific example here. My matrix A is 1, -1, 0, -1, 0, 1, 0, 0, 1. And can we do now the matrix M, which is the minors? So M11, M12, M13, M21, M22, M23, M31, M32, M33. That is going to be M11. What is that? This is going to be this 0 minus this times this 0. This is 0. M12, you cover this, you cover this. -1 minus 0, that is -1. M13, you cover this, you cover this, 0, and here 0. Now, M21, you cover this, you cover this. So you have -1 minus 0, that is -1. M22, you cover this, get 1 times 1, 1 minus 0, 1. M2, 3. Cover this, you have 0, you have 0. Now, M3, 1. Cover this, you have negative 1. Here, cover this, you have 1. And M3, cover this, you have 0, and you have minus 1. Please double check. All right. So that is the matrix of minors. And here you can write the cofactors. So that is going to be 0. This multiplied by negative, it will be 1. This is 0. This is 1. This is negative 1. Correct? 2, 2. So that is 1. It is 1. And here 2, 2. That is 1. This is 0. And here this is negative 1, 3, 1, that is 4, so it stays positive here. And negative 1, and this is negative 1. No, 3 plus 3, 6, so here that is negative 1. Okay, so you can think about the sign as follows, in case you do a mistake. So here quickly positive, negative, positive, negative, positive, negative, positive, negative, positive. Or you can think about the index here when you add I plus j. All right, so here just I'm double checking, that is fine. Then it's fine. And the last row here, that is negative 1, negative 1, negative 1, that's fine. Okay? So this is how you get the matrix of minors, and this is how you get the matrix of cofactors. Okay. Now what I did here on a 3 by 3 matrix can be done on any square matrix. Okay. So what you do here, you come to each entry, you cover the row, you cover the column that contains that entry. Okay. Then what is left? You take the determinant of that. So when you are talking about 3 by 3 matrix, you need to evaluate determinants of 2 by 2 matrices. If you are talking about 4 by 4 matrix, you need to evaluate determinants of 3 by 3 matrices. And in that case, you have to go down another time to use this 2 by 2 matrices. So you can see here, it is kind of an induction process. 3 by 3 will take you to 2 by 2. 4 by 4 will take you to 3 by 3, then to 2 by 2. So basically, you can expect here it is the long process if you want to do matrices of large size. Okay? All right. By the way, if you want to apply this here, you can do that. So here you can say, what is the minor that you associate with this? Well, cover this column, cover this row, so it is D. Okay? So the minor, here it is. The minor of A, it is D. The minor of B, what is the minor of B? You cover this, and what is left here is C, correct? And the minor of this, you cover this, what is left is B, okay? Let me double check here. Yeah. All right. So we know how to find minors. We know how to find cofactors. Now, what is the determinant? The determinant now the determinant of A is going to be A11 cofactor 1, plus A12 cofactor 1, plus A13 cofactor 1, 3, which is going to be the same as A 2, 1, C 2, 1 plus A 2, 1, A 2, 2, C 2, 2 plus A 2, 3, C 2, 3, and that is the same as A 3, 1, C 3, 1 plus A 3, 2, C 3, 2 plus A 3, 3, C 3, 3. 3, 1, 3, 1, 3, 2, 3, 2, 3. Yes. Now, of course, it needs some verification, okay? But we're not going to do that. So just take my word for it, and you can see that when you do the exercises, okay? You can use any row or any column, as a matter of fact, to write the determinant of your matrix, okay? And in general, if A is an n by n matrix, then determinant of A is, okay, let's write it in general here using any row, okay? So for the row, you can say A, I, J, let me write it, I1, C, I1, plus A, I2, C, I2, plus you keep going up to C, I-N, A-I-N-C-I-N, A-I-N-C-I-N. And that you can write it as summation A-I-J, C-I-J, J from 1 to N. And here I can be 1 or 2 or whatever you want up to N. That is the formula that gives us the determinant. Okay? Okay, so let's go back to this example and see what is the determinant of this matrix. What is the determinant of this matrix? Determinant of A in this example is 1 multiplied by 0 minus, or should I write step by step? Okay, let me write it step by step. That is going to be 1 C1 1 minus 1 C1 2 plus 0 C1 3. That is, what is C1 1? C1 1, here it is. That is 0, because cover this, we multiply. So that is 1 times 0 minus 1 here. What is C12? C12 is 1. Cover this, negative 1, and there is a negative here. So that is negative 1, and here plus 0. So the determinant of A is 1. Look here, what happens if you do it using the third row rather than the first row? So you are going to get, or determinant of A is 0, C13 plus 0, C. This is a 3, 1. This is a 3, 2, plus 1, C, 3, 3. And that is going to be C33, and what is C33? It is negative 1. And here I'm doing a mistake somewhere. All right, let's see what is the mistake. Let me go back here and double check. So here, C11, what is C11? 1 times, that is 0. Then negative 1 times the minor is negative 1, and you change that. The minor is negative 1, so that is negative 1, and now it becomes 1, so that is 1. So here there is a negative sign. So as you can see here, we are getting the same answer. We have to get the same answer, okay? And we can prove that in general. It doesn't matter which row you use, you should get the same answer. And if you are not getting the same answer, it means you are doing a mistake somewhere. Now, here there is a very easy observation you can do. Look here. What's the difference between doing this and this? Which one is more convenient? Well, here we have 2 zeros here. Here we have only 1 0. So when you have more zeros in your row, you have less computations to do, correct? And if you have a matrix, the first smart idea you can do is go to the row that has more zeros, or go to the column that has more zeros, okay? And use it. If you want to use columns, this formula becomes what? This formula, if we use columns, determinant of A, it will be what? Well, instead of running this summation over J, you have to run it over I. So this will be summation A, I, J, C, I, J, and now you run it from I equals 1 to n. And here you can do this for J, 1 to n. Okay? All right. Let's take another example in which we do it for 4 by 4 matrix. So consider this matrix B, 1, 2, 0, negative 1, 3, 1, negative 1, 0, 0, 0, 1, negative 1, and here 1, negative 1, 0, 2. Well, if you look at this, you can see here in this row you have 2 zeros. In this column you have 2 zeros. So it's up to you. You can think about this row or you can think about this column. Okay? So the determinant is going to be this 0, so what do you get here? This is A31, A32, A33. So this C33, and this negative 1, C34. So what you need to do here, you need to find C33 and C34, correct? So let's do that. Let me keep this and do it here. M33. What is M33? You cover this, you cover this. So that is going to be determinant of 1, 2, negative 1, 1, 2, negative 1, 3, 1, 0, 1, negative 1, 2. And M3, 4, that is determinant of, cover this, cover this. So you have 1, 2, 0, 1, 2, 0, 3, 1, negative 1, 1, negative 1, 0. All right, so let's find each one of those. By the way, after some practice, you should be able to do this fast. So here, when we do 3 by 3, well, you can do the cofactors, but actually, you should be able to do this mentally. Look, this is going to be 1 into 2 minus 2 into cover this, here 6. Then plus -1 into -3 minus 1. You can do it as we did before, step by step, and see, is that what you get? So here you have -12, -12, and here 2, that is -10, -10 plus 4, that is 14. Please double check that. Now, what about this? This, well, you can see here you have 2 zeros if you want to use this column. If you do that, that will help you, because in that case, all you need is just to do this. So that will be positive, negative, positive, 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 negative, positive. So that will be negative, -1, that will be 1 into 1 times -1, -1 minus 2. So that is -3. So that is the minor. So now you substitute to get the cofactor. This will be the same as the minor, because 3 plus 3 is 6. It's an even number, so this is 14. And 3 plus 4, that is 7. It's an odd number, so you have negative sign and -3. So this will be -1 times -1 times -3. So you have 14 minus 3, and that is 11. So the determinant of B is 11. Double check, please, okay? So do this step by step and double check. Make sure you get here 11. If not, I'm doing a mistake somewhere, and in that case, you have to catch that. All right. So we know now minors, we know cofactors, and we know how to find the determinant of an n by n matrix in general. You can say here you need to do a lot of computations. I agree with you. But after some practice, you find it is just straightforward, simple, okay? And we can use the computer to do the computations very fast, okay? There are easy observations that will help us to do things fast. As I said, if you have more zeros in one of the rows or the columns, then you can focus on that and use that particular row or particular column, okay? And right away, you can see here, if you have a row of zeros, all of it zeros, then right away, the determinant is 0. Why? Because you can use that row, and in that case, everything here is going to be 0. Aij, they are going to be zeros, so you get 0. So right away, you can make some easy conclusions here. So let me write that down. Facts. One. If let A be an n by n matrix, be an n by n matrix. Number 1, if A has a row or column of zeros, then determinant of A is 0. Correct? And that's very easy to see from here. Number 2, determinant of A is the same as determinant of A transpose. Why is that? Well, it is what we said here about the determinant. We said you can use any row to do it, or you can use any column to do it, correct? Of course, we did not prove that, but it can be verified, okay? We're skipping here the verification, but it can be done, okay? So this will give you that the determinant of A should be the same as the determinant of A transpose, okay? Three, if D is a triangular matrix, if A is a triangular matrix, then determinant of A is, think about it, if your matrix is triangular, upper or lower triangular, so what happens? Well, you can focus on the row that has more zeros, correct? And in that case, you end up with this entry multiplied by C44. But again, for C44, you are going to find a row with zeros except one entry. So again, you focus on that. So what do you get here? You get actually the product of the elements along the diagonal. A11, A22, ANN. So if you have a triangular matrix in front of you, right away you can see the determinant without computations. Here is an example. One, two, three, 0, 4, 5, 0, 0, -2. This is your matrix A. What is the determinant? The determinant is determinant of A is 1 times 4 times -2. Okay? Why is that? Because if you want to do it, you have more zeros here, so that is going to be determinant of A is -2 C33. Now, what is C33? This is C33. You cover this, you cover this. So that is going to be -2 into determinant of this. 1, 2, 0, 4. Again, this is a triangular. You do the same thing here. And that is -2 into 4 into 1. And that is. So if your matrix is triangular matrix, right away the determinant is the product of the elements along the diagonal. Of course, if it is diagonal, that is going to be very easy because it is triangular and it's still the product of the elements along the diagonal. You can see here the determinant of the identity matrix is 1. Okay? So here you can see that if your matrix is triangular, then it is invertible if you don't have zeros along the diagonal, because the determinant in that case will not be 0. I mean, if you don't have zeros along the diagonal, the determinant will not be 0. Okay? Now, later on, we are going to confirm the relationship between the determinant and between the inverse. All right. There is only one more idea left here, which is this the only way to do it? I mean, it seems it is lengthy, especially if you are talking about large matrices. Well, we are going to learn more methods, and you decide which one you like to use. It is up to you. However, for 3x3 matrices, there is another way. I don't like to teach it because it just works for 3x3 matrices. But you can do it if you wish, which is the following. If your matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. What you do here, you write the first column again here, the second column again here, And you multiply this, you multiply this, you multiply this, then you multiply this, you multiply this, you multiply this. And now, those minus those. So 1 plus 2 plus 3 minus 4 minus 5 minus 6. What you get will be the determinant of A. Okay? So this works, but only for 3 by 3 matrices. So that's the reason I don't like to teach it, because it's just for 3 by 3 matrices. However, if you like to use it, that is fine. Okay? All right. So that's it. That's it for today here. Next time, we are going to talk about more ideas that will help you to compute the determinant.